Welcome students. In this video, we will look at the programmatical aspect of convolutional neural network. First, we saw about the theoretical explanations, then we saw about the mathematical approach of the training process, and then we will now look at the Python language-based implementation of CNN. When I say implementation, this is not a full top line to end line related programming implementation, but I will give you the key commands, the structure, the skeleton, a framework with which you can definitely develop a CNN for your practical implementation. So first one, you need to define a model. So in our model, in the programming model, it is sequential based implementation. So when I say sequential, my one step result is very important to carry out this next step implementation. Because they are dependent, I am going to choose the model as sequential, and this model is used to include all the theoretical concepts of convolution layer, max pooling layer to implement a pattern recognition application. The syntax used is model.add and the command is convolution 2D. So when you specify convolution 2D, you need to give all the parameters necessary for this command. The first one is the filters and also the size of the filters. As I told you in the theoretical explanation, it is not only the dimensions of the filters, but it is also the content of the filters which are very important. So in this case, I say the number of filters is 2. Then I need to specify the size of the first filter, which is defined by kernel underscore size of 0, and also the size of the second filter, which is defined by kernel underscore size of 1. And also we saw about the different options of overlapping. When you overlap, always there will be a problem. If the size matches, if the filter size is 2 cross 2, and if your image size is 4 cross 4, then 4 is divided by 16. Definitely you will not face any problem. In most cases, you will find that there is always mismatch in the size of the filter and also in the original image. How to avoid that? We use a method called as padding, where zeros can be added as many times as you like in the row fashion or in the column fashion to make sure your filter size and your original image matches. In some cases, people what they do is they do not bother about padding additional data, but they will find out whatever may be the correct match, let me get that. That is sufficient for me. So in that case, what happens is the last two rows or columns would have been left out. If you have some useful data, then it is a real issue. But otherwise, you can skip those rows and columns which are not matching. So you can say, should I go for padding or not? In this case, I have not gone for padding. And if that's the case, we need to choose the variable or parameter valid. There is also another two options available in Python, full and same, where the level or the type of the padding process and everything changes. And also you need to specify the shape of the input or the dimensions of the input. Now, once you set, you form a convolution layer. Now, as we saw in the previous theoretical sessions, you need to have the activation layer also, which is going to give the output or pass from the one layer to the out. Next. So here we are making use of the rectified linear unit activation layer. It is simple and it avoids the negative value and it maintains only the positive value. Now this is one convolution layer. Suppose if you say that I want to have another convolution layer, again you use the same command and develop another one. And again you make use of the activation function whenever you go for convolution layers. So in this example, I have taken two convolution layers, but there is no hard and fast rule that you should use only two. After convolution layer, we come to the max pooling. Again, it is 2D. Whenever you have 2D, there is also another option to have 1D too. But we predominantly do not use that for signal applications, but the option is also there. So don't make mistake in specifying the 2D command in your CNN for image-based applications. So you're specifying the pool size as we have seen in our um, theoretical session. We chose a 2 cross 2 quadrant size for downsampling. Now it is up to you. You can choose 0.25, zero point 0.5, depending upon whether it is 1 is to 4, 1 is to 8, or 1 is to 16. You can choose. Now comes the dropout layer where you are going to have a regularization and to make sure that your data or neurons are not overfitting. Whenever a data or neurons are overfitting, then the chances of noise creeping into your output is very high. So we make sure that some neurons are not taken care of every iteration. This is a small option, but sometimes you can use, if you do not feel like using, you can skip too. Now comes our important layer, flatten layer, where our two-dimensional data, which is the output of max pooling, is converted into a single dimensional data for our input layer of FCN. Now the next parts are FCN, where you have the hidden layers, the dense layers, where we make use of 128 neurons in the dense layer. Again, you can have the activation function as ReLU. Again, you can have the dropout 0.5, that means 1 is to 2 neurons will be chosen. And finally, you have the command for the output layer. So here you can closely observe dense is the command which is used for hidden layer and also the output layer. If you specify the number of neurons, then it is hidden layer. If you specify the classes, it will act as the output layer. So you specify the number of classes, say for example 4, 5, depending upon your application you can give. And we have already noted that softmax is the activation function to be used in the output layer. So here comes our architecture with full convolutional max pooling and also the fully connected layer network. Then comes our training part. We saw plenty of mathematical equations in our training part. Now the question you may ask is, should we go for implementing it step by step? Exactly, not necessary. There are plenty of optimizers available for deep learning methods. You can say Adam algorithm, Ada delta algorithm, and SGD algorithm, modified SGD algorithm. Plenty of optimizers are available, which is also available as a tool in your Python software. So when in the drop down menu, you can choose anyone. I have chosen Ada delta, and because it is a classification application, I have also chosen the loss function as categorical cross entropy function. Suppose if it is a regression application, then you need to choose something like MSE or mean squared error based loss function. Now, what are the results you need? I need accuracy, sensitivity, specificity, all those things. So I am specifying my metrics. When you implement this and execute, you will get the training curves apart from the confusion matrix. And with the confusion matrix, you will be easy to identify how efficient your methodology or algorithm